All right, here we go with the second to last objective of the unit and of the semester, objective 67, which is graphing quadratic equations in standard form. So, before we talked about solving quadratic equations, and now we're going to take those solutions and we're going to use them to graph the quadratics. So, remember when we talked about solving, we would get solutions like x equals 2, x equals negative 4. We got two solutions to our quadratic equations. And we're going to see how we're going to use those to graph. So here we're going to write out graphing quadratic equations. So what these solutions mean to the quadratic equation, they represent the x-intercepts on the graph. So let's go ahead and write that out. When you solve a quadratic equation, the x values, or the solutions, uh, are the x-intercepts. So if you remember back to first semester or when we talked about linear functions, the x-intercept is where it crosses the x-axis. So let's go ahead and write that. These are on the x-axis. These are on the x-axis. All right, so let's take a look at this first example down here. Let's go ahead and solve this one. We have x squared minus 2x minus 8. So the first thing that I want to look at is, well, how can we solve this? I first start by thinking, how can we factor it? So we start with the greatest common factor. Well, I see that the numbers out in front, we've got 1, negative 2, and negative 8. The greatest common factor there is 1, so we can't pull anything out in terms of a coefficient. Let's take a look at the x's. We've got x squared, x, and then no x's. There's not any greatest common factor that we can pull out for the variables, so there is no greatest common factor amongst these three terms, other than 1, of course. All right, so now we have to figure out if we can factor this. Well, let's look at the third term. We've got negative 8. Are there factors of negative 8 that add up to negative 2? Well, factors of negative 8 we could say are like 1 and negative 8. We could say like 2 and negative 4, or negative 2 and 4. Again, you can move this negative around. Do any of these add up to negative 2? Well, I noticed that positive 2 and negative 4 add up to negative 2. So we can use those. So the factored form for this quadratic equation is x plus 2 and x minus 4 equals 0. So don't forget your equation. So this is the factored form. We factored this quadratic now. And then using what we learned earlier is the zero product property, we can solve the equation. So setting each factor equal to 0. So we have x plus 2 equals 0. That's a plus. And then x minus 4 equals 0. Well, solving for x, we subtract 2 from both sides, and we get x equals negative 2. And then for this one, we add 4 to both sides, and we get the solution x equals 4. So these are our two solutions to this quadratic equation. Now, what we said earlier, the solutions are the x-intercepts, or where it crosses the x-axis. So I see here we can take these two coordinates and plot them on our graph. So we're going to plot negative 2 here, and then positive 4 here. That's where it crosses the x-axis. All right? So let's return back to our definition. The next thing that I want to talk about is the shape of quadratic graphs. The shape of a quadratic graph, it's not a line. The shape of a quadratic graph is called a parabola. And that's spelled Parabola, a parabola. All right, so the shape looks like the letter U. Looks like a U. All right. Now, the shape can open upward or it can open downward. So if a letter U opens upward like this, a parabola can also open downward. And the way that we can determine from the equation whether or not the parabola opens upward or downward is we look at the x squared term. If the x squared term is positive, it opens upward. If the x squared term is negative, it opens downward. So looking at this equation down here, well, take a look at our x squared term. The number out in front is just 1 or positive 1. So we can assume that the graph opens upward. So you can kind of already, just from looking at the equation, kind of get an idea of what the graph might look like. All right. So we talked about x-intercepts. I also want to talk about what we call the vertex. So the vertex is the lowest or highest point on the graph. The vertex is the lowest or the highest point on the graph. So how do you determine whether it's the lowest or highest? Well, let's take a look at this one. If it opens upward, well, then it's the lowest point. It's that point right there, all the way at the bottom. If it opens downward, then it's the highest point on the graph. Okay. In order to find the vertex, we're going to say that the x-coordinate, so the x-coordinate of the vertex is the average of the two x-intercepts. The x-coordinate of the vertex is the average of the x-intercepts. So you can plug it into this little formula here. To find the x-coordinate of the vertex, you can take x1 plus x2 and divide by 2, where x1 and x2 are the x-intercepts. Okay? x1 and x2 are the intercepts. You can just plug it in right here. That'll tell you the x-coordinate of your vertex. So looking down here, well, our x-intercepts are at -2 and +4. To find the x-coordinate for our vertex, we can take both of those. So -2 plus +4 all over 2. Well, -2 plus 4 is 2 over 2. And 2 over 2 is just 1. So the x-coordinate for our vertex is at 1. All right. To find our y-coordinate, so I'm going to write to find the y-coordinate of a vertex, plug in the x-coordinate into the equation. And I'm running out of space here. Sorry, it's a little small here. To find the y-coordinate, plug in the x-coordinate into the equation. All right. So we found the x-coordinate of the vertex. We're going to go ahead and plug in that x-coordinate into the equation. So we have x squared minus 2x minus 8. So we have 1 squared minus 2 times 1 minus 8. And then we'll go ahead and evaluate this. We have 1 squared is 1 minus 2 times 1. Well, 2 times 1 is 2. So minus 2. And then we'll bring down the minus 8. Well, 1 minus 2 is -1. Minus 8 is -9. So our y-coordinate is -9. So we've got an x-coordinate and a y-coordinate. So we can conclude that our vertex is at the coordinate 1, -9. Remember, this is in the form x, y. So the vertex is at 1, -9. So let's go ahead and plot that as well. So we count right 1 and down 9. This is our vertex. And using those 3 points, we can draw in the shape of the graph. So we can draw in that U shape. And it's just a rough sketch. You can just try to make it curved. And it looks like this. All right. Make sure that it's U-shaped and not V-shaped. There should not be a corner here. It should not be a corner. It shouldn't be sharp here. It should be rounded off. So if you need to, you can kind of try to make it more round. Remember, parabolas are U-shaped. So I want to talk about some of the characteristics of a parabola or a quadratic graph. So we already identified that the lowest point here is the vertex. And then also where it crosses the x-axis, those are the x-intercepts. So that would be right here and right here. Again, just this whole graph is called a parabola. Now, is there another way that we could have found the vertex? There is. A parabola, if you might notice, if we were to put a line down the middle here, so I'm going to put my pen down here. If you were to put a line down the middle, you might notice that it's symmetrical. So if we were to draw on this line, it's symmetrical. Each half is identical. It's like you put a mirror down the middle. It's identical on both sides. So you could have found that x coordinate by just counting out. If you go one from this x intercept, you go one from this intercept, you go one more and one more, you go one more and one more. So in order to find the middle of these 2 points, you have to count 3 each way. So you might just also find the middle of that, and that's the x coordinate for your vertex. You still have to solve for the y coordinate. All right. And then the last thing that I want to talk about is looking at the shape here. This graph opens upward, which makes sense with our equation. So I always go back and double check. Does the graph make sense with our equation? It does. The leading coefficient, or the number out in front of the x squared term, is positive. So it opens upward. So that all makes sense. This graph looks great. All right. So we're going to get a whole lot of practice on this. We'll see you tomorrow in class. Have a great day.